Good afternoon, everybody, and welcome to our session for oil and gas well from drilling to abandonment. This is done by University of Misan, SPE student chapter, and University of Hadhramaut, also chapter of SPE. I will introduce myself. I am Samer Shukri. I am petroleum engineer since 1995. I am working in the oil industry for more than 25 years, 26 years till now. And I hope that we still be working. My nationality is Turkish. Experience in oil and gas. I worked for workover, well services, production engineering, well integrity, IWCF in certification, international instructor. I am authorized from UK, from Scotland. I worked for several reputable oil companies such as Syria Petroleum Company, Shell Syria, Al Furat Petroleum Company also. Then I moved to Abu Dhabi onshore company, ADCO, and worked as a senior production engineer. Then I got the certification from Aberdeen, Scotland, to be as an accredited IWCF instructor for level 2, 3, and 4, well intervention. I have my profile on LinkedIn. My name is Samer Shukri. These are the companies that I worked for. Syrian Petroleum Company. It is a governmental company. Then a joint venture, Al Furat Petroleum Company, between Syrian Petroleum Company and Shell. Then I moved to ADCO. Here is the map of UAE, Emirates. I worked here in this circle, Bab Field, Habshan. Then I moved to training, and I am accredited and authorized from an IWCF forum. Here are my certificates as an international trainer passed, and here also this is my result. All are excellent and a strong pass. Here are my you can addresses on Facebook. I make all of these only for work, nothing else. So if you go to Facebook and check, today I uploaded a video that I made last week. So always you can find something useful. It is nothing to say good morning, good evening like this. I focus on work. Also, if you send me a friend request, I will approve it, and you will utilize of it. Also, LinkedIn, if you don't have an account, it is very important to start working in the oil and gas industry. So this is a very important network. So you can, if you don't have an account, you can do it, or somebody, or I can help you. My account there is Samer Shukri. You can send also a request if you like. On YouTube also I have my own channel in this name and my photo. If you see my photo, you will see it there. So I always upload. Today also I uploaded one video there. So you can go there and see one by one, each video 2 hours, 1.5 hours. Today I uploaded 30 minutes. But I have tens of hours, but I cannot do them in one day. So every day I do them. This is my email and my mobile. This is WhatsApp. If anybody wants any help, anything, any consultation, I am ready. These are the positions that I am working for. We will let's go to our course or our session for today. We will start with introduction. We'll talk about life cycle of a well from the drilling phase till the plug and abandonment. How can we start that? We do 3D seismic survey, then we can move the drilling rig. We will talk about the types of drilling rigs, then well types, then completion types, objectives, then classification of completion and types, completion components. These are the completion components. You have to know them. I will explain to you about them. Tubing hanger, subsurface safety valve and types, production string, production packer, types, landing nipples, circulation devices, which contains sliding side door and side pocket mandrel. Then we'll go to flow coupling, blast joint, PVR, travel joint, wireline entry guide. So after that, we'll move to wellhead and see the types of wellhead, the Christmas tree types also, reservoir characteristics. Here we move to reservoir engineering. I will give you something about reservoir engineering also, hydrocarbons, bubble point pressure. All of these, I think you have studied them at the university. So when I sent you, if you remember 100 questions before, I need your feedback. You did a self-assessment, and how much did you get? 70%, 90, somebody has got any 100 or less or more. So it is a self-assessment for yourself to know yourself. Do you need some improvement, or you are less than 70%, you are more than 70, you are 50. So this will make you will give you some motivation to dig deeper in the oil industry, and don't focus only on what you have taken at the university, because the university gives you something important, or we say the subjects or some details. But when you go to the field or to the office in X company, then you have to be ready to go on. Otherwise, they will not accept you. I don't know how the employment at your companies, but worldwide, as a standard, the competent engineer will be employed. The who has more knowledge will be employed, will work. The other has to develop himself and work and study. Then he can start working. So this session you can consider it as a block for you. So you can start building. When you build a building, you need blocks. You know the blocks. You put one by one till you reach to the first floor, then second floor, and so on. So when I give you this one now, and you review after that the questions that I gave you 100, you will see that these questions are matching to these answers. Then you have to memorize them. I give you now this session. It will be video recorded, so it will be put in the on the YouTube, and I will put it in my channel also, so you can consider it as a reference for you for the future. So most of these that I will deliver for you today will come in the exams. When the company, I was doing interviews for the newcomers, for the engineers, either graduated or 10 years of experience or plus minus. Also for the contractors, owner, we have owner and contractor. The contractors also, we are assessing them. Who can pass this exam, he will take our approval as owner company. Who doesn't, we refuse him. So let him work more and study more and improve himself, because we have to trust him. And if he has no enough knowledge, in this case, he will not add any value to us. So we'll go also to reservoir drive mechanisms. This is reservoir engineering, crude oil specifications. We will go to density, specific gravity, API, The information pressure, I think most of you know what I am talking about. The reservoir calculations and laws, Darcy equation, all of these, you are brilliant in them, I think. Then initial oil in place, how to calculate the reservoir volume, how much is oil in it, how much we have a fluid in it, and the saturation. We have Boyle's law also, the gas, P1V1 equals P2V2. I think most of you know this law. Production stage, we will go. Then well classifications, gas lift system, oil types, well intervention. So we'll talk about wireline and coil tubing. Then coil tubing, we can do well stimulation in it, which has types of acidization, fracturing, hydraulic fracturing. We can go to productivity index also. Then well kill method. This is very important for the IWCF, well control. So if you need to kill the well, you have to be fantastic in these four methods. So I will explain all of them to you in detail. So then we can go to cement plug using coil tubing, well logging. This is big subject. Open hole logs and cased hole logs. Then noise log. I will explain to you also working in H2S environment. I worked in one of the highest percentage of H2S in the world. It is 37% in this field, BAB field. The maximum value was 37%. It is terrible. So all precautions should be taken and the training of personnel, equipment, etc. Then norm radiation, the equipment could be contaminated with norm. Then we go to safety and identification of hazard, such as fire, explosion, H2S. This is hazard. Then the risks, what to define them, controls, risk assessment matrix, then permit to work system, then skin factor and formation damage, barrier theory, barrier types, well integrity management. This is big, also big subject. It is big science. We can cover it. Oil production phases, we have three types: primary, secondary, and tertiary. Part of the tertiary recovery methods is CO2 injection, also I will tell you. Then corrosion, cathodic protection, HSE incident prevention, hazardous zones, then safety, unsafe act, unsafe condition, near miss, PPE. And then we can talk about incidents. I will give you two incidents happen in the last 12 years. Macondo incident in the Gulf of Mexico and oil spill. And the ADCO H2S incident, 3 people were killed in this incident. I will show you a video that was issued by ADCO also, just to increase the awareness of the whole world, not only in the Emirates, or the whole world, because this is called H2S silent killer. Memorize it. H2S, hydrogen sulfide, is a silent killer. It can kill a person at percentage of 1000 ppm. When it reaches to this level, the man will be died. Then problems that can occur in the well, we can take hydrates, paraffin wax, asphaltenes, then abandonment. Let's move on to the details of this session, of this small course. We can say that we have an oil in this area. We suspect that there is oil in this area. So how can we identify, how can we prove that this oil will be here? I think you have some idea, but I will go into detail to save some of our time. If any one of our colleagues has any question, please drop it in the chat here in Zoom or in Facebook or whatever. and Mr. Athir and Mr. Saleh will collect them, and we will discuss them at the end of this session. So we say that this company, say Shell, they took this, they did an agreement in this area of Iraq, for example, 20 kilometers by 20 kilometers. They have first to do survey. We call it seismic survey. After that seismic survey, they do interpretation. This interpretation will give us some initial results that there is possibility of oil and gas to be present in this area. So they moved it to this area and focus on it. After that, what can they do? So this is called seismic survey. It can be done on land or on sea or by satellite. So three types of seismic survey, and all of it, the aim of it is to make an image of the downhole. It can do survey till 5,000 meters or less or minus, plus minus like this. 5,000 meters, 6,000 or 3,000, whatever. It depends on the depth where the oil is present in this area or in this country. For example, in Kirkuk, they can find, in Iraq, they can find the oil at depth 800 meters. So they do survey till, say, 2,000 or 3,000. They don't need to do it till 10,000 meters. After this one, they have now an idea that in this area, we may expect that there is oil or gas. So we want to prove it. How can we do that? They move a drilling rig. This drilling rig should drill 1 or 2 or 3 wells. We call them exploration wells. In this case, we do full study for this well. It may extend till 3 or 6 months. After that, if they find a trace of oil or hydrocarbons, they can improve it and drill another well. Also, it is called exploration well. This exploration well, also, it may be one in the center of the structure in this area and one in the side. So this can be as a proof of oil, whether it is there or not. If it is there, they will go ahead. If it is not, they look for hydrocarbons in another area, and so on. So this is the idea of it. Here we have the life cycle. We start with the drilling. Here is the drilling. I told you about the seismic survey. After that, we move the drilling rig. They do the drilling. After the drilling, say that they find this well, this hydrocarbon. What shall they do? They have to run completion. It consists of tubing, packer, subsurface safety valve, wireline entry guide. All of these, we will take them now. After that, put the well in the production. What does it mean, production? It means when we invest this, for example, Shell company, they invested $50 million or $100 million. In this case, this will be the recovery stage of the investment. When they pay this one, they may find oil and they may not. If they don't find the oil or hydrocarbons, they will lose all of this investment. Otherwise, if they find, there will be an agreement with the government of each country that you have to take this percentage and we have to take this percentage. Sometimes it is 30% for the company, Shell or BP or ExxonMobil, and 70% for the government, or plus minus. It is different from country to country. After that, this production phase will extend till 10 years, 20 years, or 30, maybe plus minus like this. During this production phase, we have intervention. Why intervention? Because by years, the production will drop. If it drops, what will happen? The production will drop. We produce in the beginning 5,000 barrels of oil. After 5 years, it will be 2,000 barrel oil per day. We have to investigate. What is the problem? What can we do? So we do intervention, either stimulation or either perforation, or we can close the formation, the zone, and move to another formation, and so on. So all of it we have to do studies, and by sharing or by the reservoir engineer, by the field engineer, production, operation, we have to also to measure the pressure, temperature. We do survey for the reservoir, same as a human body, because the reservoir is very similar to human body. When you feel sick or you don't feel sick yourself, you have to go to doctor and tell him, doctor, I feel dizzy. So what is your advice? He tells you that you have to do analysis for your blood, for your pressure, for your temperature, and so on. You may scan. So in this case, for the well, we do pressure, temperature, we do logging, we do different surveys. Then we interpret it and see what is the next action that the well needs from us to do, whether it needs to be closed and moved to another zone or another reservoir. So it will be under the custodian of the production engineer in the field, and in the office it will be under the production technologist and reservoir engineer. So we are working as a team. Nobody is working by himself alone. So everybody is collecting data and move and share it with the other team. So the networking in the company is very vital. In this case, everyone knows his responsibility, what to do for this reservoir, for this production to be improved, to be maintained for the maximum use. So if we are optimistic, we will say that this well will produce for 30 years without any inclination of the rate. In this case, we have to keep the reservoir pressure maintained. How we can drill another wells nearby and inject water, inject gas, inject CO2, polymers, hot fluids, and so on. After that, when we produce everything from the well, what can we do? We have to close the well. This is similar to a human body. If you reach 100 years from your life, shall you stay alive? Most of us will die. Nobody is guaranteed that he will live more than 100 years or 200 years or 120, like this. Also, the well has to be closed in some time. So after we produce all of these fluids, we have to plug and abandon the well, and will be closed, and we look for oil in another area. So these well life cycle, we can say it in another words. So we can say design, it is in the beginning, then construct, then operate, then maintain, then abandon. So it is similar to these expressions. Here also, the life cycle of the well, we have the well construction that includes drilling and completion, then production, then maintenance. We are talking about these ones. I work in this area. So my specialist is in this area. But I know the drilling, I know the completion, I should have known. I know the reservoir, I know, but the specialty is here in this area. it is big subject. Don't imagine if you stay working for 10 or 15 or 20 years, you still need to improve yourself, because this is science, and science is limitless. As you learn, you find yourself that you need to learn more. So please do your best and study more and more and more. You are still at the university, or you are graduated, or you are working, or you are a professor or professional. All of us, I am learning every day. Believe me, I am learning every day. I am studying every day, 2, 3, 4 hours. It depends. Every day there is something new. So when you feel yourself that you are 100%, your curve, it was like this, it will move like this. You see, it will stay for something stable like this, but at the end you will start dropping, because you feel yourself overconfident. When you are overconfident in oil industry, there is no overconfident. You are learning every day. Nobody, if for me, if I am 100 or 90% in my specialty, in work over well intervention, maintenance, lifetime extension, all of these, I have to look at the drilling. I have to look at the reservoir engineering. I have to improve myself. So I see every day what any new technology that I can utilize it in my ways. I can deliver it to my trainees. How can I do that? I monitor and watch videos. These videos can give you the summary of others' experience. Now, after we finish this session, when you sit down, you and by yourself only, and watch this video for 2 hours or 2.5 hours, I am sure that your ideas will go ahead, will move forward. Why? Because you are improving yourself. This video plus previous video plus previous video plus next video plus this is sharing from engineer Samer experience. I move to engineer X and see what is he saying in his specialty, in drilling, in reservoir, in production. Then move to another. Then I motivate myself to work as a researcher. I can move, I can study by myself. Then you will see yourself fantastic. You will see yourself an expert. So at the end, I will do for you experience exchange. I think for this will be starting point for us, and I promise you to give you some of my time to give you experience exchange. This experience exchange for me, every day I remember what I have done in this year, in that day, in that month. So I write it down. All of these, I will deliver them to you, discuss with you, explain what happened, what should have been done. We did this way in the wrong way. We should have done it in this correct way, and so on. So this is building your experience, and will move you ahead, and you will see if you work and study, I am guaranteed that you will feel yourself. Now you started with 50% or 40%. After 1 month or 2 months, I am guaranteed that you will jump from 50% to 60%. Why? Because you are lucky you found somebody that he can catch your hand and move you forward, and tell you that this, you have to take them and memorize them, and then when you sit down with your professor or your doctor and you tell him something like this, he will be surprised. Where did you bring this information from? You tell him, I study, I am working on myself, I am improving, I want to be same as you. I want to be a doctor or professor or international expert. Why not? Who became professors or doctors, they were same as you. In 1990, I started my university, and I was a student, same as you, at the university, and studied hard and worked on myself. And nothing will come to you and will tell you you are Superman, or you have 100% expert in your specialty. So you have to work and you will find it. I am guaranteed and 100% sure that you will get it at the end. Here we can take this one. We can say the life cycle of a well. With starting of the well and construction will be drilling and preparation for 18 months, 1.5 years. Then this is preparation. Then the drilling will be 2 to 3 weeks, maybe 1 month, maybe 2 months. It depends on the geological conditions that can be encountered and the depth of the well. If we drill 15,000 feet, it will be different from if we drill 2,000 or 3,000 feet. If it is vertical, it will be different than if it is horizontal, and so on. Then we do the preparation. After the rig move, we do the preparation, or if the rig is on site. But for the time being, we release the rig. It will run the completion, and we come and do this one, this stage. We do clean out, we do stimulation, we do perforation, we do frac, logging, all of this after running the completion by the drilling rig. After that, we do the production. As I told you, it will last to 20 or 30 years, or plus minus. It may be 10 years, maybe 5 years. After that, we need workover to come and isolate this producing zone and move to another zone, or do side track, or do the vertical well to be as a horizontal well, and so on. So every well will be different from the other well. Every field will be different from the other field. So some fields, as I told you, Kirkuk field in Iraq, we can find the oil at depth 1,000 feet, while in Rumaila we can find it at depth 6,000 or 7,000 feet. In Abu Dhabi we can find it at 9,000 feet, and so on. So this is very easy for us, no problem. We deal with it as the condition of the well is like this. We deal with it. Now I can show you the video from drilling to production quickly, because it takes time. I will pass it for you. Here is the drilling phase. Here is the drilling. The drilling system here. Here we have the drilling. We're running the completion. We run the completion after completing drilling. The stage of the drilling. The perforation. The operation. And completion. This is in summary. Here, 3D seismic. Also, we talk about it. You can look at it and fix the screen in this. If you want more data, you can read it carefully. You see all of this. Here, as I explained to you, we do a seismic survey. We send the sonic wave. It will reflect. This is the source explosion. Then it will reflect from this layer. Here there is geophone or recording channel, and it will record the delta T. Delta T is the difference in time between sending and receiving. Here are the geophones, these. And here a geophone group, and here recorder track. It will go to the computer, then it will be interpreted. Here also in the sea, the survey ship, also they consider this length of water from the sea water, from the sea level to sea bed. Here, say 800 meters, for example, then they will send the waves, source of shock waves, air gun. Then it will reflect from the surfaces of the layer, like this. Here, I can give you an idea about the IWCF. Everyone needs to work in the oil field, should be qualified and competent to work, and should have a high awareness regarding the well control. So we have two types, drilling and well intervention. Drilling, that is a different section, they study the drilling subjects. For us, in the well intervention, we give the completion equipment, completion operation, wireline operation, coiled tubing operation, snubbing operation. And we have 4 levels, level 1, 2, 3, 4. 4 is the highest for engineers and supervisors. Here, this is for operators. Then here, introductory, here, awareness. And there is a certificate, and there is exam, very hard exam. It is done by the IWCF forum in Aberdeen. They monitor you via video camera, and you have to write. It is online. You open the computer, they give you the questions. After that, you answer whatever you know. If you pass 70%, you will take the certificate. Otherwise, you have to repeat it. And it is costly. This course maybe $1,000 or more or less. So you have to prepare yourself to work there. Otherwise, you have to study, keep studying. Now, this is the first thing for you to know what is this IWCF. This is given by UK, Scotland, and Aberdeen. There is another certificate is called IADC. It is given by Texas, by America. So in America, they depend on this IADC certificate, but in Europe, here in our countries, they depend on IWCF. But the whole is the same principle. You have to work safely and know what to do in case of an emergency, and you have to know what is the completion, what is the component, what is the operation, calculations, blah, blah, blah. All of these. So I give you now an introduction for that, so that after that, when you see anything, you understand that this is related to this one. So I have to study. This is related to this one. So by time, you will be expert. Now I deliver this course continuously anywhere in the world. Now, for the time being, I deliver it online. But normally, when there is no COVID-19, we do it face-to-face in the classroom. Same as here, they attend it from different countries. You can find the attendees, one from UK, one from France, one from Italy, one from Malaysia, one from Uzbekistan. So, but they hear what I explain and see, and they do the exam, and all of them either pass or fail. It depends on the knowledge of everyone. So these are the calculations. I know, I am sure that most of you know these calculations, so you have to know them, because you have to memorize them as if your name. Nothing else, and they are very, very easy. I memorized them more than 20 years ago or 25 years ago. So as if my name. If you ask me anything, and when you memorize them, you will take, now you say 10% of IWCF, if you memorize only this one. So by the end of the course, if you study it very well, you will take 70%. So IWCF is not easy, and at the same time, it is not difficult. But you have to know the subjects that are delivered to you. So if you are willing to learn, you can learn. Here, drilling rigs, we have 5 types of drilling rigs. We have one for land, or we call it onshore rigs, and the other type is offshore rigs. It depends from jack-up rig to semi-submersible rig to drilling barge and to drill ship. Now you will ask me, what is the difference between jack-up and semi-submersible and drilling barge and drilling ship? What is the difference? All of them are rigs. No, it depends on the depth of the water. Jack-up will start with the shallow well. I will show you here. You see, here is the drilling land rig, this one. It is onshore. All of these are offshore. So here we can drill in shallow water, maybe 200 feet, 400 feet, like this. But here we can go to 500 feet till surface. So this one is from surface to seabed, sea level to seabed, 500 feet maximum. Jack-up. For drilling barge, it may be till 100 feet, shallow water, 100 feet, 50 feet, like this. Then if you go deeper in the water, the difference between sea level and seabed, it will be here semi-submersible, 10,000 feet. Then drill ship, we have in Turkey here, we drill in the Black Sea and White Sea. Mediterranean Sea, we have 2 drill ships. This is used for deep water, for up to 12,000 feet. I will show you the photo of each one. You see, this is the land rig, this one. I am sure most of you have seen it. Then barge, this is shallow drilling, maybe 100 or 50 feet or like this. So it is shallow barge rig. Then jack up till 500 feet, this one. Then semi-submersible, this when the seabed is far away from the sea level, by up to 10,000 feet, this one. Then drill ship, as I told you, this is Yavuz drill ship. It is drilling in the Black Sea, in Turkish water. So it also, the other one is Fatih drill ship. So it is drilling till 12,000 feet for the distance of the seabed and sea level. Here we are working in a very dangerous industry. Guys, please pay attention with me. We are not going to the party to do a party, or to the theater, or to playground to watch a football game. We are dealing with the most dangerous industry in the world. So you have to be aware of it, and you have to train yourself to study and see what will happen if something goes wrong. So if you see these incidents, you will count till 10 before you go to the next step. I will show it not to make you frightened, but to increase your awareness and make you practical more, because these happened with most of the people who work in the oil field. Look at it, please. You see, this is oil and gas flowing from the well. In this case, if any spark or fire comes to here, it will fire. It will kill everybody on the rig. So the awareness and experience, you see how many workers are here there? 5, 6. You see the helmets? 6 people. And here is the drilling supervisor and the tool pusher. So they are trying to fix it, but it is difficult, but at the end, they have to fix it. Otherwise, it will escalate and maybe a disaster will happen. You see, they connect this one. At the top of it, there is valve here. This tube, this pipe, they connect it with difficulty. You see? After that, they run it and close the valve and secure the well, kill it. You see? It is not easy at all. We call it well blowout. You see, up here, they install a valve. When lowering the tubing down, they will close the valve and secure the well. After that, they can kill it. So if there is H2S here, it will kill everybody on the site. It will not stop. Here also, the rig. You saw the rig without fire. Now I will show you the rig with the fire. Very dangerous. You see the pipes, drill pipes also, they fell down. This is in Russia. Russia blowout. What can they do? Can you help them? The rig has gone. The rig has gone. Another one. You see this one. This is similar to previous one. Also blowout. I will pass it. Same as the previous one. They connected this pipe and they will lower it down. Then you close this valve. Secure the well. Next. Also this one, working without killing the well. Look at it. It is very dangerous. Yes. They are pulling the completion while the well is flowing, not killing it. So here in IWCF, they will kill you. They will, they will not allow you to work in anywhere in the world. This is breaking all rules. This is breaking all something standard. So it is not allowed like this one. So you have to calculate the kill fluid. You have to kill the well to do as per procedure. So you have to be respectable. For these ones, they can die at any time, at any minute. Look at them. How can you go there and I give you $500 or no guarantee? No, nobody can go there. Amazing, amazing. Anyone can wants to work like this one, it is against the law. Anyway, we can move ahead to wells. The wells can be, I told you, exploration when we drill one well or two wells or do three wells. It is a new area. After that, when we discover the hydrocarbons, we can drill wells, maybe 10 or 20 or 100 wells. We call it a production well. The wells can be vertical like this. Then the horizontal, we go this, then this one, or deviated by this one, like this. So three types: vertical, horizontal, and deviated. And the types of the well, we have oil producer, gas producer, water injector, gas injector, WAG injector, water alternative gas, we call it. We inject, it is an injector well. We inject 1 month water, then 1 month gas, then and so on, 1 month by 1 month. This is to prevent the producing water in the production well fast. So we improve the enhance the efficiency of the water injection. Then water supply well, then water disposal well. Here is the completion. The completion is the tubing that is run. This is the completion. You see it. This is tubing conduit from the reservoir to the surface. And here we have the packer. Here it isolates the annulus. Here is the annulus. It isolates it from the reservoir. So because by time, after 10 years or 20 years, if there is a problem in this completion, we can move work over and replace it easy. But if the casing is corroded or damaged, how can you replace it? It is fixed with cement. The cement is fixing it behind it. So in this case, you will not be able to do anything, or you have to spend more time to either repair the casing if it is corroded or it's leaking water or like this. So it should be isolated using packer. Here, either we can run the casing till the end of the completion, the reservoir here, to the top of the reservoir, and where the completion can be single like this one, or can be dual like this one. You see multiple zone completion, and here case perforated completion, and here open hole completion. Here are the types of the completion. I can tell you these ones. Here we have single vertical. Also, we talked about packer and isolating the casing here. And we have the tubing. We have single selective also. This single selective, we can produce here from one reservoir only. Here we can produce from lower, middle, and upper reservoirs. So 3 reservoirs can we produce either from this one using close. We have here SSD. Close this SSD and close this SSD and produce from here. Or we can isolate this reservoir using plug here and open this SSD, close this SSD. Or produce from this one by isolating this one, close SSD. Set the plug here, wireline plug, and open this SSD. And so on. This strategy of production from the well, it depends on the reservoir engineer and the plan that he is putting it to produce the well for 20 years or 30 years or plus minus. Here, this can be done using single completion. We call it single selective and vertical. Here we can use also, if we want to produce or inject from 2 zones in the meantime, we can use dual, and this is vertical. We can, here this is injector. We can inject this one gas to the lower reservoir. And in the meantime, we can inject water to the upper reservoir. So in the meantime, and in the other side, we can produce also, we can produce the upper zone of, through the short string and produce the lower zone from the long string. So we can utilize both production and injection. Here also single string. When the reservoir pressure is low and we want to produce the well at maximum without any obstruction, we don't run completion components. You see the completion components here and in the other completion are not there, the components. Why? To prevent any obstruction of the reservoir fluids from preventing these fluids to flow through the completion to the surface. So we call the reservoir fluids, the flow, we have 2 types of flow. We have inflow, which is producing the hydrocarbons, which is water, oil, and gas, from the reservoir to the wellbore. We call it inflow. Then the outflow, the other type, is producing these or the flowing of these fluids from the well, from the wellbore to the surface facilities through the Christmas tree and here the completion. So these 2 types, you should know them. Here to the surface facilities, here we have also the production station that has test separator. This test separator, we can separate oil, water, and gas. You see, this one we have two types of wells depending on the trajectory of the well, either vertical here, vertical well, or horizontal. We can drill vertical, then we can do like this, or we have a deviated well. And here are the components. You see them? We can take them one by one, and I will give you all these components. So most of these, if you know them, you will gain another 10% of IWSF. So by the end of the session, you will pass it very easily. Here we have types of pumping. When the reservoir cannot sustain natural flow, what can we do? We have to use artificial lift. We have four types of artificial lift. We can start with the gas lift system. We inject gas into the annulus to the side pocket mandrel. Here we have gas lift valve and produce it to the surface. When there is no liquid here, no oil and water here in this section, it will close. Then the other gas lift valve will open and produce this one, and so on. It will be repeated like this. When we have no production at surface, we stop injecting gas and wait till the reservoir to build up, and we can resume gas injection. Otherwise, if we still producing using the gas injection through the annulus to the tubing, we continue gas injection. Or if we don't produce, we can stop. The other type will be here. We have ESP, electrical submersible pump. When we have reservoir that has high water cut, when the percentage of the water is, say, 80% or 70 or 90 or 95, and the reservoir can deliver high rate, we cannot run ESP when the well can produce 1,000 barrel or 500 barrel, because it will produce net only 10 or 20 barrel. It is not economic. While if this well reservoir can deliver 10,000, for example, barrel per day, in this case, if the BS&W is 80%, in this case, how many barrels will produce? You can calculate it. Every 1,000, it can produce 200 barrel. So 200 barrel times 10,000, it will be 2,000 barrel. It is economy. While if you produce 10 or 20 or 50, because this is very costly, the ESP and the system in general. Also this one. So you have to be logic when you choose your artificial lift or the secondary production method. We move on to the third type, which is beam pump or saccharose pump. We run a reciprocating pump here, and we have standing valve in the bottom and traveling valve in the top, and saccharose. Saccharose could be 1 inch OD or 3/4 inch or ½ inch. It depends. It depends from the design. But in general, we use 1 inch and 7 and 8 inch. And we run the small size in the bottom and big size in the top. Why? Because the load will be bigger in the top rather than the low, the below. Here, if we have the well can deliver 1,000 or 1,500 barrel per day gross, we can run it. Here we move to the fourth type of artificial lift. We have a PCP, progressive cavity pump, this one. We have motor at surface. It can move the saccharose. This is saccharose. And here we have stator and rotor. Stator here, this one, it is fixed. You see the stator, it is fixed, this one. While the rotor, I will show you now in a better photo, a closer. This stator, this rotor is rotating. And here we have like caoutchouc or rubber inside. And here like chromium or nickel or like this. I will show you. When it is moving like this, the well will be produced through the tubing to the surface. But it is used when we have very little production and the oil is very thick. When we have normal oil, these wells like a tar. You know the tar, which we make our roads using it. Very, very thick. So when we produce it to the surface, what will happen? We mix it with light oil, then its API will increase. When it increases, or we can also boil it, or we increase its temperature. So the increasing of the temperature will reduce its viscosity. When you reduce the viscosity, you can pump it. Otherwise, you cannot. The pump will get stuck. You see, this is the typical permanent completion. These are the components, main components. You see, these are like this. And the depth, this is, for example, actual example. So 10,000 feet, the reservoir depth, and we run the completion till here. Be above the end of the completion will be above the top of the reservoir by 150 feet. So we can produce like this. This is single vertical completion. Here also we have the completion components like this. We can go through them one by one. We have to make a barrier. This is considered as a barrier. We can protect the reservoir from the surface and prevent any incident by putting a barrier. You know the barrier? It can prevent the flow of the well from the reservoir to the outside to the environment uncontrollable. You have to control the flow of these fluids. The flow of these fluids should be under your control. Otherwise, you will lose the well and you may lose yourself also. So we have to think about it very carefully. We call it in oil industry barrier policy. What is the barrier policy? We produce from this well to the surface. We should put when we work well intervention, we should put 3 barriers, not 2 barriers, 3 barriers in well intervention. In a drilling, we put 2 barriers minimum. We say minimum. You may put 4 or 5, but minimum as per IWCF barrier policy in drilling 2 barriers, in well intervention minimum of 3 barriers. This barrier may be BOP, maybe stripper rubber, maybe Christmas tree, maybe so all of these shear seal BOP, equal BOP, dual BOP. So all of these stripper, grease injection head, I will explain to you each type of them. So these are barriers. They can prevent the flow of the well fluids uncontrollable. So you have to flow, but under the control. If they are out of your control, will happen same as what you have seen now. I showed you just to open your mind and think seriously that this industry is very dangerous. It is not easy. So you have to think about it. I will explain to you through the video what is this barrier. So look at this boy. Here we have this risk hazard. We say this hazard, this boy, our baby is running, and his mother is looking at her mobile as normal. Most of the mothers are doing like this, and her boy or her baby is running towards this one, this baby. So he didn't study what we are studying now. He is not aware. So there is a hazard here, but he can go and drop himself. But what can you guess what will happen here? Who can help him? His mother or us or anybody else? Look at it, please. You look, this is clever. He didn't study same as what we studied. He didn't watch videos. You see, look at it. He is aware that the boy or the baby will drop himself in the pit. Look at what he did. All of the time spent. You know that it's always that. Yes, I don't know the perfect road to go down, but I know. I like it. I like it. He is very clever. He thinks more than the mother of the baby. So I will pass it to you again just to think deeply in it. It's dangerous. You know that it's not always Get out. He put this barrier. He put it to prevent anybody to drop in the pit. Very clever dog. This is called barrier principle. We move to the next slide. This is tubing hanger. We run it at the top of the tubing. It can hold the weight of the tubing here at the top at surface, and we can put inside it a two-way check valve, this one, or back pressure valve to install the Christmas tree or to do securing of the well. We will pass them very quickly, but we have to give you an idea because each one needs 1 hour to explain about it. Here, this subsurface safety valve is to close the well in case of an emergency, and it has two types: surface-controlled and subsurface controlled. These valves, if there is any fire or any damage in the Christmas tree or a flow line at surface, they will close the well automatically by releasing the pressure or releasing the hydraulic pressure in the control line. So they can make it and close the well in case of an emergency. This one. Here, this is the subsurface safety valve. We have types: wireline retrievable and tubing retrievable. And this is the safety valve. It has a flapper. This is open, you see, and this is closed. You see this one, this flapper is closed. This is open. And we can call it downhole safety valve, surface control subsurface safety valve, surface safety valve, tubing retrievable safety valve, different names for the same element. Here, the flapper, you see it, flapper open. You see this flapper. This flapper is closed, the well is closed, the safety valve is closed. You see this one, we saw it. We can move to production string. Production string, the tubing that is allowing the flow of well fluids from the reservoir till the surface. So we call it production string, tubing, like this. You see it. And we have here, normally it is 10 meters plus minus, this one, tubing. While these, this is the coupling, we call it this green one J55, this type. This red one C75, and so on. we have different types. We have here the body and the coupling. You see the coupling, and here short joints just to make space out while we drill the well. Here, when we increase the pressure inside it, it will rupture. You see, it will get ruptured like this. So we have rules and laws. We have to study them to avoid such incident. It will stop the well for 1 or 2 months till we repair it. So while if you work as per procedure, I tell you international procedure standards. So, but if your company is not taking care, in this case, you have to expect more incidents, more losing of money, of people, of like this, and also the damage to the environment. The packer I showed you, this packer, we have to isolate the casing above the reservoir from the reservoir, because the reservoir has a pressure, temperature, has corrosive fluids, has H2S, CO2, etc., etc. So if it will be in contact with the casing, it will corrode it. It may burst it also. In this case, what will happen? We keep this casing safe. You see, we have rubber and we have slips here. This is called what? Packer. This is single packer. This is dual packer. This one. Landing nipples also, we run it. We have 3 types of landing nipples. We set here pressure flow control devices, we call it. Flow control devices, this one. We install flow control devices in it, so we can isolate this zone from other zone, or for testing the tubing, or for setting the packer, or it has different functions. But we have to know what is an idea about it. Landing nipple. We have no-go landing nipple. It is run at the end of the completion. We have only one one piece only. Selective landing nipples, we can run 3 or 4 or 2 or whatever we need for isolation, for setting plugs, for testing, and porting or safety valve nipple. Sometimes the safety valve, tubing safety valve, will get damaged or get stuck. What will happen? We isolate it using locking can and keep it open all the time and run inside it the wire retrievable. Where shall we set it? In this safety valve landing nipple. Here also no-go landing nipple. Here selective landing nipple, safety valve landing nipple. Here circulation devices. We have 2 types of circulation devices. We have, if we want to kill the well or to produce from a specific zone. If we have 2 packers, we have a zone between them. We isolate it by closing this zone, by isolating this zone using the closed SSD, sliding side door. If we want to produce from this zone, we have to close this SSD and produce. In this case, we use this SSD. This is installed below the packer, between 2 packers. Sometimes we only or install it in the position of above the packer. Why? Because we want to kill the well for the workover. So we open it, circulate the well, then we close it, then the workover will move and replace, for example, the completion. So it is used as a circulation device. The other type is side pocket mandrel, which is part of the gas lift system. This side pocket mandrel, we run inside it different types of gas lift valve. We have gas lift valve, dummy valve, circulation valve, dump kill valve, chemical injection valve. We have different types of valves. But for circulation here, we use it for circulation. We run circulation valve, just to do circulation from the annulus to the tubing or vice versa. Here we have sizes 1 inch and 1.5 inch. This gas lift valve, it is small, very small, not 1 inch like this or 1.5 inch. And it has two series, OM 1, 2, 3, 4, 5, and the other type also 1, 2, 3, 4, 5. Here the SSD, you see it. We have holes. You see the holes. This is the sliding sleeve. It is a sleeve, and it has holes. When these holes are shifted to this one to be opposite each other, what will happen? Like this one, it will be open like this one. But if you shift it down, this is a blank. It will be closed. This one, SSD. This is also SSD. This is closer. Here, kick-over tool, when we run or pull the gas lift valve in the side pocket mandrel, this is side pocket mandrel. We run it here. There is a place for the different types of the gas lift valves. We run it using the kick-over tool, this one. It has an arm. This arm is moving, and this is actual valve in its place. We have flow couplings and blast joints. When we have experience that there is corrosion or erosion in the well, we run flow coupling or blast joint. This flow coupling has ID more than the ID of the tubing normally. The OD is the same OD of the tubing. Why? Because, as you know, we have two types of the flow. We have laminar flow and turbulent flow. When we have turbulent laminar flow, there is no problem. The well will flow by itself. While when we expect that there is turbulent flow and there is a high possibility of the erosion to happen, for example, at the F nipple or R nipple. So we run either upstream of it and downstream of it, or only the downstream of this completion component. For example, subsurface safety valve, the nipple of it. So we run downstream of it. Otherwise, we run upstream and downstream. Upstream means below it, and downstream after it. So in this case, we protect these jewelers. We call it completion components jewelers. They are as if a jewel. These jeweler, we can protect them to serve us for the maximum time, period of time. In this case, we don't need the workover to move, and it has high expenses. So we save this one and reduce the time also that the well will stop producing. In this case, we produce it. When we have producing well between two packers, and we have high velocity from the reservoir to the formation, and in this case, maybe there is sand, maybe like this, we install between two packers a piece called a blast joint. This blast joint has a bigger OD than the tubing, normal tubing. But for the ID, it has the same ID of the tubing. So in this case, as there is here erosion, especially if there is sand in the reservoir. If this erosion occurs, what will happen? It will be eroded, but with a small thickness. Small thickness, but we have already bigger wall thickness for this blast joint. In this case, it will be no problem for us. it will protect this piece and will flow the well for 10 years, 20 years without any problem. Flow coupling, this one, it has, you see, above and below the crossover. You see it? Above and below the landing nipple, subsurface safety valve nipple. So these are as we told. And it has a thick-walled pipe. Thick-walled pipe, this one, flow coupling. Also, from the turbulent, if the excessive turbulent flow is expected. You see, I explained that to you. This one. Here we have polished bore receptacle. We can show and travel joint. We can show you when we expect that the tubing will move up or down due to thermal change, expansion and contraction. What will happen in this case? This piece or this one will get out of this one. So the male will get out of female. What will happen? The fluid of the reservoir will be exposed to the casing, and this will be very dangerous. So we put this one male inside the female here, and here, and we make it move. So if we have a high temperature, what will happen? For the metal, it will expand. If the metal expands, what will happen? Its length will increase. When it increases, the length will increase. All of it will go inside this female, this one. So we have calculations that it may increase by 20 feet, for example. So we make our calculations based on this one. And in this case, we serve the well. In the other side, if we have water injector, wet water injector, we inject cold water. If we inject cold water, the tubing will expand. The opposite of contraction, the high temperature, is the contraction. If the tubing is contracting, its length will be less. You are talking about 8,000 feet or 10,000 feet. So for this length, the increasing or decreasing in the length of the tubing will be 20 to 40 feet. This PBR or travel joint or expansion joint or whatever it has different names, it will contain this movement of the tubing, either positive or negative, contraction or expansion, increasing in temperature or decreasing. So this is very important invention that we can protect our well from exposing the casing to the formation fluids, pressure and temperature. Here, wireline entry guide, it is installed at the end of the completion. We can run it because we run the wireline tool string outside of the completion to the formation. After that, if it wants to enter again to the completion, if there is no suitable tool at the end of it, it will be cut or it will get stuck outside of the completion. So we run this one. It is called wireline entry guide. We have two types, bell guide, this one, and the mule shoe, this one. Each one has different position and different circumstances. Wellhead, well, I can show you the wellhead. Here we have the casing here. Casing, we start from conductor, production surface casing, intermediate casing, and production casing. Here we have the hanger and wellhead of the casing. You see the wellhead. Each one, you see this one for the surface production casing. Here the intermediate, here the production casing. And here we have a tubing hanger that holds that tubing. The tubing is this one in the green color. It isolates also the tubing from the annulus. You see, this is the annulus between casing and tubing. Also, we can install the Christmas tree. This is called Christmas tree. You see it, Christmas tree. It is a combination of different valves that we can control the well through it. This is called a barrier. We can use it as a barrier. We can open the well and close it. So it can, all of these tubing is barrier, packer is barrier, wireline plug is barrier. So, and we have barrier envelope. Each envelope has different barrier elements. So this, you can learn it later on. But now if you understand this one, it will be fantastic for you. I know that I give you more information, more data, but if you understand just the principle, if you repeat the video 1 time, 2 times, 3 times, you will be fantastic. But now you can understand what I am telling you. Here we have the different types of the Christmas tree. This is the conventional one. This is called monobore. So monobore for high pressure wells, it is one piece. And here we have lower master valve, upper master valve, flowing valve or production valve. Here killing valve, we can kill the well from here. Here swap valve, and here also tree cap. Here also the same. If you want to work in the oil field, you have to memorize these items, these elements, same as your name. Here you see this is monobore Christmas tree. This is high pressure, 5,000, more than 5,000 psi gas well. This one. Here we have actuator, lower master valve. It is actuator. Upper master valve is actuator. It can close and open the well. Also here on the wing valve we have actuator, either hydraulic or pneumatic. Here you see the workshop, they are fixing this one. The Christmas tree, we have 3 types, conventional, mono block, I showed you, and compact or subsea. This is for the subsea. You see, this is the wellhead. This is normal photo for the wellhead. Here below it, there is the wellhead and casing. And here is the Christmas tree. Here is. You have to memorize, even if you don't want to work in the oil field, but if you go to visit, site visit to any well, and the production engineer will explain to you, you have to know better than him because you studied and you attended us in this course. So if you don't memorize them, it will not be okay. So memorize them. Here also monobore, 1 piece, and here also the well. These are for subsea. We have 2 types, vertical and horizontal. You see, like this. Here, remotely controlled. From the surface, we have control, or they can send a machine, they can control it. Sometimes they send the diver or like this, so they can control these wellheads, Christmas trees. You see, this is for dual Christmas tree. This one. So short string and long string. This is for beam pump. You see, this is called polished rod. Polished rod. This is, we can produce the well from here. We produce to here, and here we read the pressure. Here is the annulus. We measure the wellhead pressure, the annulus pressure. Here, this is for wellhead for Christmas tree ESP wellhead. So we run the electric cable in the annulus behind the tubing to the ESP. So we can operate it from the surface using the electrical current. Here, origin of oil and reservoir. Most of us have studied the origin of oil, and it came from the decay of the plants and animals under pressure and temperature in the sedimentary rocks, and they took maybe 10 million years or plus minus. After that, they were compressed, and under pressure and temperature, they moved from condition to another. So this is called source rocks. For reservoir rock, when the rock is formed, I will go there. You see, when the rock is formed in this source rock, it will move to the reservoir rock. It will stay here. You see, this is also impermeable cap rocks. It will prevent the hydrocarbons from moving up. It could be shale, this one. It could be any other rock. For these ones, it should be permeable and has porosity, has high porosity. And these are the types of the traps. We have anticline, fault, stratigraphic, reef, or salt trap, and so on. So you studied them, I know, in the university, but you can review your information here. Here also, we have another, the migration from the generation rock, source rock, up. Normally, source rock is deeper than the reservoir rock. Here the accumulation. So if we drill here, we will produce oil. If we drill here, we will produce oil. Here we find only gas. It is gas cap. So there is supporting for the reservoir pressure from the oil, water here, and water here. So if we drill a well here and inject water, it will keep sweeping the oil and gas and will keep the well flowing. Here, this is perfect reservoir. You cannot find it like this. It is in the computer only. So you can find it here, gas in the top, then oil because it has higher density, then water, that water has the highest density in the fluid. So just I want to tell you about the difference between fluid and liquid. The liquid is oil and water. This is liquid. It is it is not gas. So we call it liquid. And in the meantime, we call gas, oil, and water fluid. So we call reservoir fluids. So you have to differentiate between liquid and fluid. So the gas is fluid. Water is fluid and liquid. Water is fluid and liquid. So I think it is clear for you. Here also, this is source rock, reservoir rock, and here in the top we have cap rock. Here we drill an oil well. We produce from this. The upper part is gas, the lower part is water. We can drill in the same structure, maybe 10 or 100 wells. There is no problem. And we have patterns to drill, maybe drill here water in the middle, water injector in the middle, and around it 4 producers, or the opposite. Oil producer in the middle and 4 water injector wells around it, the square or hectagon or sexagon or like this. So 6 or 8 wells or like this. So it depends on the pattern of the field development. Here also the types of the traps. You see it. You can see it. Reservoir characteristics. We can talk about the porosity, which is the reservoir voids. You see the voids or the spaces, the total volume of it to the total volume divided by the total volume of the rock oil, including all the bulk oil, the bulk volume, it is called porosity. It varies from field to another field. It varies from, in general, 5 to 40%. It is 5 the percentage between V pore, the volume of the pore, to the volume of the bulk. So it is called, this is called porosity. While the permeability, what is the difference between permeability and porosity? The permeability is the ability of the rock to flow the fluid. You see, I told you to flow the fluid. So if it is high permeability, then the fluid will pass easily through this rock. So we take advantage and we will use it for more production. While if it has low permeability, the productivity will be less. So we try to improve this permeability by doing stimulation, acid, mud acid, or like this. Hydrocarbons also, the combination of carbon with hydrogen. We have methane, ethane, propane, butane, hexane, butane, pentane, and like this. So hydrocarbons is the structure of the petroleum. You see, this is the petroleum and natural gas. You see this one. So we can take from this petroleum many products like plastic, fiber, rubber, solvents, explosives, like this. Hydrocarbons can be found underground in the structure of this, as I told you, methane, ethane, propane, until we call it CXHY. CX, for example, CH4, C2H3, C3H8, and so on. These are bubble point pressure. We have to keep a pressure in the reservoir high enough to avoid separating the gas from oil in the reservoir. You see here there is no liquid. What did we agree? Liquid, water and water and oil. So if it goes drops below the critical point, this critical point, bubble point pressure, we will produce only gas. So only gas, what is the benefit of it? We don't need that. Here, when we increase it to above this bubble point pressure, we'll produce only liquid. So we have to be around this point. So avoid making the reservoir pressure to drop below this bubble point pressure. We don't want to drop below it because the gas will move the oil with it to the surface. But this is called one phase flowing production. So if we leave the gas settle down alone without producing the oil with it, what will happen? It will produce gas, and this gas is not expensive, same as oil. We need oil, so we have to keep it. Reservoir mechanisms, I will tell you, we have different types. We have solution gas. You see the gas is here, so soluble inside the oil. Here, after a period of time, the reservoir pressure will go down. And here, as we talked, this is the critical point. Here, gas cap drive. Here we have gas cap separate. So the gas cap will compress on the oil and leave it to produce through the well. You see it like this, gas cap. Here we have the water flood, we have this one, depletion drive. Depletion by itself, there is a pressure, the pressure is more than bubble point pressure. But here, by time, the bubble point pressure, reservoir pressure dropped below bubble point pressure. What happened? We produce oil plus free gas. This is not good. So we have to drill a well here and inject water to support this reservoir pressure to produce, because the well will remain in the reservoir, we produce only gas. And this is the right way to produce from the well. Here also water drive. As we talked, we have to support the reservoir pressure using water injectors here and here. Inject water and this oil will be produced to the surface. Here gravity, here nothing, just the oil will go down and the gas will go up. You see there is no support. So we produce from here the oil and the gas will go up. There is combination of more than one drive mechanism of the reservoir. You see here we have gas cap here. In the meantime, we have water support. You see, water mechanism drive here from the bottom water and from the top gas. And here we have specific specifications of crude oil. We have density and specific gravity. Here in the laws, we have this one. We can measure using hydrometer the specific gravity of the oil or water or any fluid. API also, the density of the fluid, it was introduced by American Petroleum Institute. This, as it is high, it will be better, and the gravity will be less. And it will be better, and we can sell it in a better price. So the API of the water is 10, fresh water. If it is heavier, it is heavy oil, or it is this is heavy water like salt water. It has API less than 10. While if we have more than 10 API, it is for oil. So the oil, if we have a very good oil, it will be API 40 plus, 40, 45, 46, 43, like this. Below it, normal oil. Here, formation pressure, we talked about it. We have normal pressure, abnormal, and subnormal pressure. You see, we can talk about them in detail. Normal pressure, formation water, fresh water, this one has a pressure gradient of 0.433 psi per foot. This is fresh water. This is standard for us, and the gradient is specific gradient is 1. There is heavier than it, but this is our reference. Here we have reservoir calculation, Darcy equation. I think you know what I am talking about Darcy equation. We can calculate the production that can be resulted from differential pressure, and here is the constant. K is the permeability, is the area through this section. We say this section we imagine it as a reservoir. So the delta P, differential pressure between the end of this reservoir and the beginning, so P1 minus P2 is the delta P. K is the permeability of the reservoir. A is the cross section, this one. Mu is the viscosity, and L is the length of this reservoir. Productivity index also, it is J, we call it productivity index. We have the unit of it, stock tank barrel per day per PSI. It is the equation between production and differential pressure. You see, this is example. Initial oil in place. Also here we have the equation to calculate how much volume of oil, original oil in place. We can call it initial oil in place or original oil in place. It has this equation. This equation can give me the original oil in place. We have this constant. We have the area in acre of the reservoir area, and here we have the thickness in feet. We have the porosity. It doesn't have a unit. We have water saturation, average water saturation, and at the end also we have formation volume factor. This one, BO. All of these we can calculate how much. For example, this reservoir has 5 million barrel of oil, stock tank barrel. So we can put a plan to produce these 5 million barrel for 10 years or 20 years as per the country policy. Here also Boyle's law, we can say that as you increase the pressure, the volume will decrease. So PV equals constant. As you increase the pressure, the volume will decrease. If you decrease the pressure, the volume will increase. You see this one. Look at it, please. We have here pressure. The pressure, if it increases the pressure, the volume here will decrease. But if the pressure decreases to here, the volume will increase. You see, this is very important law in the reservoir. Production stage. We come now to production stage. After we put the well, completion, drilling, perforation, logging, all of these, we have to produce the well and start counting money resulting from this well. So we have to see that this is the well, and it flows to the station. Here we can separate the gas from oil from water, and water is sent and injected into water injector well. Gas is sent to the gas plant for treatment, and water will be treated. After that, it will be exported. Here we have a classification of wells as per production method. We have primary, secondary, and tertiary. Primary, when we produce the well without any support, without any help. But if we start injecting water and gas, in this case, we call it secondary. And we have different types of this secondary for mechanical. That can help the well to produce. We took them gas lift and pumping. Gas lift, I explained to you. Pumping, we have ESP, beam pump, PCP, and jet pump. For tertiary, we call it enhancement oil recovery, EOR. It is called EOR, tertiary production. We have too many methods for that. We can pump polymer, we can pump chemical, heat, carbon dioxide, explosions, different types. You see here gas lift system. We inject gas to here and produce to separator here. So here gas lift mandrel and gas lift valve inside it. Here also we have this one, gas lift. Here we have ESP, gas lift valve, this one, gas lift system. You see here bottom. This is what do we call it? ESP. You see here, this is the ESP. That previous one, gas lift system. Here is the electrical submersible pump. So we have motor, we have electrical cable, we have intake, we have pump, we have equalizer. So all of these, you see, ESP. We have beam pump. I will show you the beam pump actually, because you see it on the television always, or it is famous maybe in some countries because it is a secondary production method. So I will show you. You see here we have insert pump here. We have standing valve in the bottom and traveling valve in the top, and second rod, and this is reciprocating movement. You see it. You will see it in the video now. And up and down, it will produce to the tubing, then to the surface, to the flow line. Here the stuffing box I showed you. If you remember polished rod, I told you this is polished rod. It is connected to the surface unit. We call it surface unit, beam pump. This is beam, and this is pump here. This is pump, and this is beam. And here is motor. And equalizing, here counterweights. We have equalizing balance. Counterbalance here, and here is downhole pump, and from the reservoir here. Now you can look at this one. You see, can you count how many wells are producing here? Very nice scene, I think. You see, I think this is in the US. You see. All of these are beam pump wells. The flow lines here also, but very wide, very big field. I think it is in Texas. This is heavy oil, we call it. Then next video, you see, this is dancing beam pump. You see, look at it, dangerous. Very nice. Here is the PCP that I told you. This might be a chromium or nickel or like this. This is the rotor, and the stator is the rubber. This one, the red one, and here it is rotating through the motor here, and it can produce the oil to the surface. You see, here is the jet pump. We pump fluid here inside it, and we produce. Gas lift system here also. This is a dummy valve. This is gas lift valve. We can set it in the side pocket mount. You see here is test separator, test package. We have test separator, choke manifold. This is test separator. Crude oil also. We have 3 types of crude oil. West Texas Intermediate. You see it in the TV always, every day. This is the benchmark of the oil. We have a Brent. and we have Dubai crude, and we have other types, but these are the most famous types of the oil. You see, Brent, I will show you. This is the Brent. You see, it is in the North Sea, between Norway and UK. Here is the Aberdeen, and here they took sample from this oil, very small oil field. This one, you see it. This is more clear. This is Norway, Denmark, and here is the UK. Here is the Brent. A very small field, and they took a sample of it to be as a reference. The other one, this one from Texas. Here is Texas. They took sample, also called it West Texas Intermediate. Reservoir monitoring, we do surveys, same as what we talked about the human body, pressure, temperature, the pulse, the blood analysis, all of these. But here we call it bottom hole closed in pressure survey, bottom hole flowing pressure survey, pressure fall off survey, pressure build up survey, interference test between two wells, integrity test, capacity test, modified isochronous. So all of these we can do them and interpret them, then take action. You see these well intervention. It has a slick line and coil tubing. This is the slick line. In general, I will hurry up a little bit because we passed the 2 hours now, and we will finish within 5 minutes. So this is the stick line, and this is it has types, 3 types. The wire line has 3 types. Wire line has a slick line and has braided line and electric line. So each one has different specifications and different functions. We can explain them later. You see, this is to wire line to the string, and these are the tools to the string. You can see them in the field. Fishing operations also, we can talk about them. Study case, braided line, electric line, slick line, braided line, electric line, 3 types. For electric line, we can do logging, perforation, and water shutoff. Perforation, you know it. You can perforate the casing to allow the fluids to produce from the reservoir to the well, and from the well to the surface. Here, study case also. Here, you see, this is wire line operation. Here, stuffing box. This is wire line, stick line. And here we have a grease injection head. This one, grease injection head for braided line and electric line. Here, coil tubing. We can do a session for coil tubing if you want. You see, this is coil tubing. It has it is metal pipe, has OD 1.5 inch, 1 3/4 inch, and 2 inch. There is less and there is more. As we like to run, it depends on the situation. And here is the result. I will pass them just for you to know. Here, nitrogen kick-off, perforation, open and close SSD, also using coil tubing in the horizontal well. Well stimulation to enhance the productivity of the well and remove any damage. You see, acidization. Here is pre-stimulation and here post-stimulation. Here we have hydraulic fracturing. All of us know about hydraulic fracturing. I will show you this one. You see, who wants to work here? Here is the well. You see, and all of these bombs are dealing with this well. So it is not easy job. You cannot imagine this. Very complex, but if you have procedures, everyone knows what to do. So every one of us could be the supervisor or engineer for this operation. So you have to prepare yourself for this such operation. Sand clean out also and scale. We clean it using coil tubing, milling, fishing, pumping. Also, we have different types. Workover, this is the workover. I was working with workover like this for 4 years in the first company that I worked for. This is also, but I see it dirty, maybe covered with oil. So sometimes you are working and the oil starts to flow, and it can cover the whole rig. We were in the when we finished this operation, we were moving the rig to the workshop and clean it and send it to another one. Well kill methods, it needs also more explanation. Different types. Well logging, we have also 2 types, cased hole and open hole log. Working in H2S environment, norm, hazard, risk assessment matrix, this one, permit to work, skin factor and formation damage, barrier theory, I showed you the video also, hydrostatic and mechanical barriers, 2 types, mechanical barrier and hydrostatic. Classification of barriers also, these, we have BOP, stuffing box, we have also grease injection head, stripper, all of these. Well integrity management system also. Well, this is well life cycle depending on well integrity. Well pressure envelope, this one. Also oil production phases. I will stop here just to show you the slides. I will not talk. CO2 injection. Safety, here is safety. This is incident happened in the Gulf of Mexico, Macondo well, this one deep water. You see they drilled 2 relief wells to secure the well. Here is H2S, and here is the incident that happened in 2009 here in this field. It is called Shafi. And then ADCO issued a video, very, very useful video. We can see it also later on. Problems that can occur in the wells scale. We have hydrates, we have also asphaltene, paraffin, wax. All of these can obstruct the flow of the well. Abandonment, when we want to close the well will not produce anything. We can close it and it will be like this. We put a 3, this plug, cement plug, it will be, could be 200 feet, this one and this one. We set before it MBBT, we call it a plug, and above it we pump cement using coiled tubing. And here, three plugs to isolate it. The last one, the well will be like this one. It is dead. May Allah mercy it. So this is the hole. We can go to this first one. Till here, I think 2 hours exactly. 2 hours exactly, we finished our session. Mr. Athir.
Many thanks, Mr. Salman, for your information, for your lectures. Really valuable information, valuable webinar. We are really appreciate what you give us today. Many thanks, sir.
Thank you.
Now we go to receive answer from the comments and from the Facebook. The first one, Mr. Kalam Isa, you can open your microphone.
Assalamu alaikum. How are you? Thank you, Mr. for this great and perfect lecture. I have 2 easy questions. What's the difference between the seal and the trap?
Between?
Seal and the trap. difference between it.
Seal
and the trap.
Where is this seal?
Seal and the trap.
You mean the reservoir trap?
Yes.
So we have a reservoir.
Okay.
The shape of this reservoir it is called the trap. Okay. We call it trap. We have 5 traps, 5 types. Anticlinic, clinic. We have faulty. We have different types. I showed you in the presentation, if you remember, if you come back to them. While the cover rock, it is sealing. It prevents the movement of these hydrocarbons to move up. It seals it. It may be shale. It may be other reservoir. But this has zero permeability, zero porosity.
I watch it. I can't different trap. Don't if they will seal.
Sorry.
Okay.
Sorry, your
The
voice
seal,
has
the seal.
The
seal is the soldier of the trap. If we don't have seal, we don't have trap.
The hydrocarbons will migrate from the mother rock to the
source rock to the reservoir.
To the reservoir.
Okay.
Where there is a rock that prevents it from moving to another rock, it is called the trap. This one.
Impermeable rock.
Exactly, permeable rock. It has high porosity. This rock will be filled with hydrocarbons. If it is a trap below this trap rock, we call it cover rock. Then it will stop. It will not move up. Okay. It may be shale in general shale. It is very it is very hard, tough.
Okay. Do you upload this lecture on the YouTube or the Facebook?
Mr. Atir will upload it, I think. Mr. Asir?
Yes, sure. I will download it on my channel on Telegram.
Okay. Thank you. And the lecture, to repeat it, PDF or PowerPoint, sorry.
Sure. We will upload it on Telegram.
Okay, thank you very much.
You are welcome. Thanks for your answer, Mr. Samuel. Let's go to the next question with Mr. Salah. Mr. Salah, you can ask your question, please.
Okay, teacher, you hear me?
Yes.
Salah with you.
Yes, Mr. Saleh, go ahead.
Teacher, thank you so much for your lecture, and we appreciate that. The slide was very, very great. We understand them, and we understand the lecture, all the lecture. So thank you so much.
Thank you.
And teacher, I have a question. My question is, there is a gas reservoir between Saudi Arabia and Yemen, and it's close to Yemen, but it's at high depth, beneath a salt formation. So there is a company in the past, Shell company, have drilled, but they stopped because the high depth, they didn't reach to the reservoir. So my question is, the drilling now is able to drill for more than 2, 3, 4 kilometers to reach to the location, the specific location?
Sure. You can drill till 10 kilometers.
2.
The maximum depth that was reached for the time being about 10 kilometers.
That's mean if a company now drilled, they will be able to drill and predict the gas from the reservoir.
Yes, you can do it, but sometimes here, especially on the borders, what they do. Most of the countries, for example, if you see the north field between Qatar and Iran, you see it, or between Kuwait and Saudi Arabia. There is one field, but it is divided between this country and this country. So sometimes what will happen? What will happen? This, for example, Yemen, if they want to play with the other side, for example, they drill a horizontal well. This horizontal well can go through the reservoir of the other country, for example, Saudi Arabia. In this case, they will steal it. You catch my point. I give you an example. It is normal in the worldwide, this one. So there is a regulation here. In this area, you cannot drill like this horizontal to avoid thieving or stealing the hydrocarbons of the other country. You catch my point?
Yes.
So
yes, I understand you.
So in this case, there is an international role, so everybody should be happy. So in this case, there will be no struggle between countries. And this is known in the political laws.
Yes. Thank you, teacher. Teacher, what about the directional drilling? What about the directional drilling? Because there is no weight on bit. You know, we for a long depth. So how will be the solution?
It is an excellent question. I will answer you. We have something called MDW and measuring while drilling. Okay. Measuring while drilling. This one, you can direct your bit to the direction and the angle that you want. Okay, you can give it a signal, so it can go to this side, so you can drill wherever you want. Okay.
I think his internet is not connecting and he's lifting this meeting. Thank you for your answer, Mr. Samer. Let's go to the question from the comments. And this question from Aqil. He asked why we prefer production from primary reservoir mechanism than gas gap.
Say again, please.
Okay, sure. Why we prefer production from primary reservoir mechanisms than gas gap?
Yes, the gas gap, we don't produce it. We want it to press on the oil. What we mention as, if there is hydrocarbons in the reservoir, we have to produce the oil. The reservoir and water can press the oil and push it to produce to the surface. Our aim is to produce water, to produce oil first. We don't aim to produce gas, except in the gas wells and the gas reservoirs. Gas reservoirs, we know that we produce only gas. But if we have oil, we have to focus on the oil. So when we want to do perforation in the reservoir, where do we perforate? We don't perforate in the gas interval, and we don't perforate in the water interval. We perforate in the middle of the oil reservoir. In this case, we have to produce from the oil reservoir. What shall gas do? It will compress down. It will compress on the oil. And what will water do? It will compress up to push the oil. This oil, if it is compressed from up and down, where shall it go? It will be produced to the well, and from the well to the surface facilities.
It's a clear answer. Thanks for your answer.
Thank you.
I think the last question is from Mr. Ibrahim. Mr. Ibrahim, if you can open your microphone, please.
Can you unmute him, please? He is muting.
Yes, I give him
Now you heard now?
Yes, yes, go ahead, please, Mr. Ibrahim.
Yeah.
My boss, this is my boss, 25 years ago.
Yeah, we were colleagues, Mr. Samer. Mr. Samer, so thanks. It's good and useful lecture. And the subject is very interesting.
Thank you.
I'm proud of you. Really, I'm proud of you that we work together, I think, more than 7 years.
Yes.
Thank you.
Thank you. I appreciate you. You were supporting me all the way. I started working as a workover supervisor, and you were having experience for more than 15 years. So
Yes.
I was proud that you were a good supporter for me. So
Yeah.
again, I appreciate it.
You work on the rig Cardwell, I think.
Yes, yes, Cardwell rig, yes.
Cardwell 10,
Number 8.
10.
Number 8.
8.
Yes.
أيوه.
You moved me more than 25 years ago. Now moved me behind. We are still young.
Thank you, Mr. Samer.
Thank you, boss. Thank you, Mr. Brian. Thank you. Yes, Mr. Athir.
Thanks. This is the last question from Mr. Ibrahim. Thanks for you, Mr. Samer, for this valuable lecture. We are really happy to invite you to this lecture, and we hope to take another lecture in the University of Misan chapter. Many thanks for you.
Thank you.
Mr. Samer, and many thanks for all one has attention this lecture.
Thank you very much.
And thanks for you. And this is the end of the question. Have a good night and goodbye.
Goodbye.